Bismillahirrahmanirrahim. Assalamu alaikum. Welcome to KS Academy. My name is Abdullah and this is module number 3, which is last module of concrete mix design using Microsoft Excel series. In the first two modules, we have covered the first 4 steps of ACI mix design procedure, and in this module we will be covering the remaining 6 steps of ACI mix design procedure. Now I will just open Microsoft Excel. We are in step number 5, which is water cement ratio, and we will be finding it from table number 5.17, which is given in ACI mix design procedure. This is the table. So we will be finding it for air entrain and non-air entrain. So first I will find it for non-air entrain. So I will just copy it, paste it here. Then for example, it is given that the compressive strength is 6 psi. So I will be using VLOOKUP function, which is VLOOKUP, and I will just select the target value, and then I will select the target table, which is this one, and the target column is 2 and exact match, and then OK. So for automation I will be using data validation. So data validation, and select list, and then select the target column, which is this one, and click OK. Now when we change value in this cell, so the corresponding value will change and will appear in this cell. Now we will repeat the same step for air entrain. So I will just copy it and paste it here, and now these I will copy these values, especially the compressive strength. So I will just copy and paste it here, and again I will use in VLOOKUP function. So VLOOKUP, and select the target value, which is 5000, and select the target table, and the target column is 3 and exact match. So it is done. Now what we will do, when we change value in this one, so it will automatically change. Now the compressive strength is given in the properties. So I want to link the compressive strength given in the properties to this compressive strength, this one. So this I will click on equal, and it was F5 seal. Also this one equal to F5. So the seal was F5. So this is now completely automated. Now I will be pasting it to respective seals. Sorry, this will be in non-air entrain, and now I will just move it to the respective seal, which is air entrain. Now we have to pick our desired value from these two values. So I will be using F function. F value in this seal is equal to non-air entrain. Return me the value of non-air entrain, which is this one. Otherwise give me this one. So this is done. Now I will equate this to the seal for automation. So now if I change the value in this seal, for example air entrain, so the values will automatically change. Now we have step number 6, which is cement content. So to find weight of cement, I will just divide the cement volume weight on this air entrain. So this is the weight of cement. Now to find the volume of cement, I will just divide this by the specific activity of cement, which is 3.15, and divided by the unit weight of water, which is 62.4. 1 over 62.4 So this will give the volume of water cement. So this is the volume of cement. Now we have step number 7, which is coarse aggregate content, which will depend on nominal aggregate size. So we will be finding the percentage of coarse aggregate from this table given in ACI mixed design procedure. So I will be finding row numbers and column numbers, and fineness modulus will be given to you. So I will just copy this and paste it here, and I will also copy fineness modulus and paste it here. And now I will be using match function to find row. So match and target value and target column, which is this one, and exact match. Okay, similarly to find column number I will be using match function, match the target value and the target row, which is this one, and exact match. And as I have moved the value of fineness modulus, so I will just write it here, 2.6, and okay. So now it is okay. To find the value of percentage, I will just use index function, index, and I will just select the target column and rows, which is this one table, and I will just select the row number and column number and press OK. So 0.48 will automatically appear, which is corresponding to 0.375 and 2.6. So move it to corresponding cell, which is this one. And now to find the weight of coarse aggregate, dry weight, so I will using this formula, which is equal to percentage of coarse aggregate multiplied by the dry roded unit weight of coarse aggregate, and multiplied by 27, as we are designing for 27 foot cube or 1 yard. So multiplied by 27, press OK. So this is the weight of aggregate, coarse aggregate, and to find volume I will just divide this value by the specific gravity of coarse aggregate and by the unit weight of water, which is 62.4. so over 62.4. okay. And now we have step number 8, which is fine aggregate content. So to find fine aggregate content, we will subtract all the volumes from 27, because we are designing for 1 year. So 27 minus volume of water minus volume of cement and minus the volume of coarse aggregate and minus the volume of air. So this one multiplied by 27. So we will get volume of fine aggregate, and so to find the weight of fine aggregate or sand, which will be dry weight, so multiply this by the specific gravity of fine aggregate multiplied by unit weight of water, which is 62.4. so this is the weight of sand. So this is step number 9, which is water adjustment. So we will be finding weight of coarse aggregate, sand, and water from coarse aggregate and water from sand. So to find weight of coarse aggregate, I will use this formula, which is weight of coarse aggregate, dry weight of coarse aggregate multiplied by 1 plus moisture content of coarse aggregate, and okay. So this is weight of coarse aggregate, and weight of sand, which is this one, dry weight, multiplied by 1 plus moisture content of fine aggregate. And okay, now to find water from a coarse aggregate, we will be using the formula, which is weight of coarse aggregate multiply by moisture content of coarse aggregate minus absorption. So this will give this value. Similarly, water from sand, so weight of sand multiplied by moisture content of fine aggregate minus absorption. So this will give this value. To find final water content, we will subtract the water from coarse aggregate and from sand. So E22 minus this one minus this one. So this is the final volume of water. Now we have step number 10, which is final step. So we will be finding cement bag. So I will use round function, and volume of cement divided by 1 bag cement volume, which is 1.25. Okay, so 3 bag will be required. Now to convert this to kgs, so I will multiply this by 0.45, so this will convert to kg. Similarly, to convert the weight of coarse aggregate into kg, so I will multiply by 0.45. Now to find the water in gallons, so I will just divide the water divided by 8.34. so I will just round this, so by using round function, round. Okay, so 28 gallon will be required. Now to find the ratio, I will just divide all the values by the weight of cement, so this by this and this by weight of cement, this one. Okay, and stone, which is this one, by weight of cement. So this is the ratio. Now to round it up to 2 digits, I will just round it to 2 digits. So 2, and similarly this one, round and up to 2 digits. Now to find the max ratio, I will be using a function. Select this one and ratio, then and select this one and then and ratio, and then this one and click OK. So this is the final ratio. Now I have to do some formatting, so I will insert box and this box, and I will equate this to this cell, which is the ratio cell, and click OK. So I will just do some formatting, this one, and the shape outline and shape fill is none, and then I will change the size to 36 and just extend it, and I will bold it, and then I will change the color. The color of numbers to red, And so this is the final mix ratio. Now I will just move it here. Now this is the automatic template. When we change the properties, so it will automatically change. So non-irritant, so the ratio will automatically change. So this is the final template. Thank you for watching.